Hi students, in the last few classes we discussed some important problems from module 3. Today let us discuss some important problems from module 2. Most of these questions are collected from the previous year's question paper. And the first question is, calculate the escape velocity from a star of mass 6 into 10 raised to 26 kilogram and radius 9400 kilometer. And in order to solve this problem, we have to know what is the formula or relation for calculating escape velocity. As we all know, the escape velocity can be calculated using the formula VE equal to square root of 2 gm by r, where g is the universal gravitational constant and m is the mass, r is the radius. And all the quantities are given in the question. Mass of the star is given and radius of the star is also given. And since universal g is a constant, it will be given in the question paper, or you can get it from the Clark's table. And given that m is 6 into 10 raised to 26 kilogram, r is 9400 kilometer, that is 9400 into 10 raised to 3 meter. We have to convert into the SI unit, that is meter is the SI unit. And the value of G is 6.67 into 10 raised to minus 11 kilogram inverse meter cube second raised to minus 2. And substituting all these values into this equation, we will get the escape velocity. That is VE equal to square root of 2 into 6.67 into 10 raised to minus 11 into 6 into 10 raised to 26 divided by 9400 into 10 raised to 3. This can be written as 94 into 10 raised to 5. And by multiplying these quantities, we will get this as 80.04 into 10 raised to 15. Now, it is very easy to find the root of this equation. That is square root of 0.8514 into 10 raised to 10, and the square root of 10 raised to 10 is 10 raised to 5. Then by finding the square root of this value, we will get this as 0.2917. Then we can rewrite it as 2.917 into 10 raised to 4 meter per second. And in kilometer per second, we can write this as 29.17 into 17 kilometer per second, since kilometer is 10 to the power 3. So hope that all of you got this problem, and let us go to the next problem. The second question is, we have two stars of masses 12 into 10 raised to 30 kilogram and 15 into 10 raised to 28 kilogram respectively, separated by a distance of 2 into 10 raised to 5 kilometer. Find the gravitational force between them and what will be the potential energy. Here we have to calculate the gravitational force and gravitational potential energy. And this is a direct question. If we know the formula for calculating both of this, then you can find the answer very easily. So the formula for calculating gravitational force is F equal to G m1 m2 by d square. G is the universal gravitational constant, m1 m2 are the two masses which is given in the question, and d is the distance between these two masses. It is the separating distance between these two masses. And the gravitational potential energy can be calculated using the formula minus G m1 m2 by d square. And as you all know, the negative sign represents the work is done by the gravitational force of attraction. That is why we put a negative sign here. And given that m1 equal to 12 into 10 raised to 30, m2 is 15 into 10 raised to 28, and d is 2 into 10 raised to 5 kilometer. You have to convert into meter, that is 2 into 10 raised to 8 meter. Now substitute the value of all this. Substituting all these values into the equation, F equal to 6.67, F equal to Gm1 m2 by d square. Then we will get F equal to 6.67 into 10 raised to minus 11, which is G, and m1 is 12 into 10 raised to 30, m2 is 15 into 10 raised to 28. And here we have to put d square. D square is 2 into 10 raised to 8. It is 2 into 10 raised to 8 whole square. Now by calculating this values, we will get the force as 3 into 10 raised to 33 and the unit of force is Newton. And the gravitational potential energy can be calculated using the formula minus Gm1 m2 by d, and again substitute these values into this equation. That is, G is 6.67 into 10 raised to minus 11, m1 is 12 into 10 raised to 30, m2 is 15 into 10 raised to 28, and divided by 2 into 10 raised to 8. Now by solving this, we will get Es minus 6 into 10 raised to 41 joule. As I already mentioned, the negative sign here represents the work is done by the gravitational force. Okay, let us move into the next question. Calculate gravitational potential energy of Earth-Moon system if mass of Earth is 6 into 10 raised to 24 kilogram and mass of Moon is 7.3 into 10 raised to 22 kilogram and Earth-Moon distance is 38,400 kilometer. Again, this is a question asked in 2018 October. And again, we can calculate gravitational potential energy using the formula equal to minus Gm1 m2 by d. But here this Earth-Moon system, therefore I replace the mass m as the mass of Earth, capital M, and small m represents the mass of Moon, and r represents the radius. The distance between Earth and Moon. Now all the quantities are given. M is 6 into 10 raised to 24 kilogram, that is capital M, that is mass of Earth, and small m, that is mass of Moon, is 7.3 into 10 raised to 22 kilogram. And you can calculate the potential energy using the same formula as we discussed in the previous question. And R is also given 38,400 into 10 raised to 3 meter. Here given in kilometer, but we have to convert into meter. And as we all know, G is again 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. Now substituting all these values into this formula, we will get Es minus 6.67 into 10 raised to minus 11 into 6 into 10 raised to 24 into 7.3 into 10 raised to 22 divided by 3844 into 10 raised to 5. These two zeros can be put together to this, then we will get 3844 into 10 raised to 5. Now by solving this, we will get the gravitational potential energy as minus 7.6 into 10 raised to 28 joule. As I mentioned in the early question, this negative sign is nothing but it represents the work is done by the gravitational force. Okay, let us move on to the next question. Acceleration due to gravity at Earth's surface is 9.8 meter per second square. Considering Earth as a sphere of radius 6400 kilometer, find acceleration due to gravity at an altitude 64 kilometer. What will be the acceleration due to gravity at a depth 100 kilometer from Earth's surface? And here it is required to calculate the acceleration due to gravity at an altitude of 64 kilometer. And again we have to calculate the acceleration due to gravity at a depth of 100 kilometer. So we have two equations, that is, this represents the variation of gravitational constant due to altitude, and this equation represents the variation of gravitational acceleration due to gravity due to depth. So in the first case, the formula for calculating the variation of gravitational acceleration due to gravity, gh equal to g into 1 minus 2 gh by 2h by r. And h is the altitude and r is the radius of Earth, and g is the acceleration due to gravity. And it is given that h is 64 kilometer, that is, we have to find the acceleration due to gravity at an altitude 64 kilometer, and kilometer can be converted into meter as 64 into 10 raised to 3, and g is 9.8 meter per second square, and r is given as 6400 kilometer, that is 64 into 10 raised to 5 meter. Now substituting all these quantities into this equation, we will get gh as 9.8 into 1 minus 2 into h is 64 into 10 raised to 3 divided by 64 into 10 raised to 5. Now we can calculate the 64 and 64. Here 10 raised to 5, that is in the numerator, it is 10 raised to 3. Then this 2, by combining these two, we'll get this is 10 raised to minus 2. 2 into 10 raised to minus 2 is nothing but 0.02. Now GH equal to 9.8 into 1 minus 0.02. Now by multiplying these two quantities, we'll get 9.604 meter per second square. And from this, it is clear that the acceleration due to gravity decreases the altitude. Now, next, we have to calculate the acceleration due to gravity, that is the variation of acceleration due to gravity due to the depth. And for this, we can use the formula GD equal to G into 1 minus D by R, and D is the depth. That is, we have to calculate GD at a depth 100 kilometer. Now 100 kilometer can be converted as 10 raised to 5 meter. 100 into 10 raised to 3 is nothing but 10 raised to 5 meter. Now substitute these values into this equation. Then we will get GD equal to 9.8 into 1 minus D is 10 raised to 5 divided by, and R is given as 64 into 10 raised to 5. Now we can cut this 10 raised to 5 and 10 raised to 5. Then 1 by 64 is nothing but 0.0156. Now 9.8 into 1 minus 0.0156, we will get the answer as 9.647 meter per second square. Don't forget to put the unit. This is very important. The unit of acceleration is meter per second square. Again, from this, it is clear that the acceleration due to gravity again decreases as the depth increases. Okay, let us stop here. Thank you.